When your games and applications start getting bigger, more exciting and full of extra features, it will be more and more challenging to keep your code clean and organized. Over time, people came up with the general reusable solutions to commonly occurring problems. These well-tested and widely used code structures are called design patterns. Design patterns are a toolkit of tried and tested solutions to common problems in software design. You could split design patterns into three main categories. In this class, we will use state design pattern to control player character in a game. It's a behavioral pattern that lets an object alter its behavior when its internal state changes. Why do we need to manage player state? Let's say we have a simple side-scroller game. Our character is standing, and when I press up arrow key, I want it to jump. This code has a bug. If I keep pressing up arrow while jumping, player character will fly off screen. So I have to do a check here. Only run this code and jump if character is standing on solid ground. Great, that fixed it. I also want to add sit-in animation, but player can't enter sit-in state while it's in the middle of jump. Player can sit down only when it's standing or running on solid ground. Maybe I also want a dive attack when player tackles enemies from the air. Again, this move can only be entered by pressing down arrow key while jumping, because when we are standing, down arrow key will make players sit down. I'm sure you can imagine how adding more moves will create a very complicated if-else statement, and since all of that is contained in a single piece of logic, adding one new move later on can break all your other existing conditions, and you will have to review that single massive logic tree every time you need to fix a bug or add a new feature. Since this is a very common challenge game designers had to deal with for a long time, there is a tried and tested way to do this right. What if instead of this complicated spaghetti code if-else statement, we model our code structure based on finite state machine? We want to have a limited set of states player object can be in, such as standing, jumping or sitting. Player object can only be in one of those states at a time, and for each state, it will only react to a limited set of inputs we define. That way, we have a class for each state, and in rules of that class, I can say that while player is jumping, wait for a certain time before switching it to falling state, or if you detect down arrow key input, transition player into diving state. Other than that, while in jumping state, ignore all other inputs. So pressing down arrow key while jumping will switch player into diving state. Pressing down arrow key while standing will transition player into sitting state. In this class, we will learn how to implement state design pattern in a side-scroller game. We will learn how to use the native JavaScript modules to split our code into multiple parts, and many other important game development tricks and techniques as usual. Click like if you are ready to start building bigger games and learn how to make our code bases scalable, easy to navigate in, easy to manage and debug. We are diving into more advanced territory today. The challenge for beginners will mostly be to keep track of what each class and function is doing and how they interact with each other. Check out some beginner-friendly game development tutorials in the video description if you just recently started with HTML, CSS and JavaScript. I created a simple web page. This doc image will be our sprite sheet. You can download it in the video description. It was made by this amazing artist. Check out his site for more game development art assets. I include my image as IMG tag this time. That way I can wait for the image to get fully loaded before I run any JavaScript. I include my JavaScript by using a script tag, but this time I will set its type attribute to module, like this. This will cause the browser to process any contents of this particular script as JavaScript module, which will allow us to split our code into multiple separate files and use import-export keywords to connect the data inside. You can see I'm importing only the main script.js file, but we will also have player.js, state.js, input.js and utilities.js. Splitting files like this makes our project a bit cleaner and easier to navigate in. JavaScript modules allow us to split our programs into separate parts that can be imported where they are needed. Node.js had this ability for a long time, but now modern browsers support module functionality natively. Use of native JavaScript modules is dependent on the import-export statements, and we will cover how to use them today. It's easy, don't worry. There is only one catch when using modules. You need to run the code in some kind of dev environment. You need to have a server. If you just write index.html file and click to open it in browser locally, as you can do with all my other course projects, import-export keywords will not work. You need to run this code through a server. There are many ways to set up a local server. The easiest one is to install a small plugin to your code editor. I'm using Visual Studio Code, and when I click here on the left side on the extensions icon and I search extensions for live server, I find this plugin. It's been downloaded over 17 million times, so it's very popular. Mine is already installed, but if you don't have it, it will say install here. After installation, you might have to close or reopen your VS Code. When it's successfully installed, you will see this Go Live icon right here. If you never used it, it can act a bit unexpectedly. When you click Go Live, it doesn't open the file you are looking at the moment. It will run code from the entire project folder your VS Code is currently pointed at. To make sure your live server goes live with the correct set of files, you click File in the top left corner and then click Open Folder, and you navigate to your project folder on your local computer. When you find it, click Select Folder, and then when you go live, the correct project will open. If you can't see this new live server notification area, close your VS Code completely and reopen it, and it will get loaded. The best thing about Live Server extension is that when you save any of the project files, it will reload browser window automatically. You can always see the latest preview of your code without constantly manually reloading browser. On my Windows computer, I use Ctrl+S keyboard shortcut to save changes to my file. I use it a lot while working in this environment. So now we should have a project folder running through Live Server extension. We have index.html file, style CSS, main script.js file. We will have player.js, where we write all the logic to control and animate our player character. State.js will be where we write state design pattern to swap between different player states. Input.js will handle keyboard input, and Utilities.js will have small useful functions that, for example, display status text or some other small tasks. I will speed up CSS setup because that's very basic. Global reset to make sure the page looks the same across different browsers. I will give Canvas some background so we can see it, and I will hide the sprite sheet image, since we will be drawing and animating it with JavaScript. I will also show you how to create a very simple loading screen. I wrote this h1 tag with an ID of loading, so I grab it here, I center it in the middle of the page, and I adjust its font size. Script.js is my main module, which will connect all other parts into a final piece of logic. The sprite sheet we are using today is a big image file, so it might take a second to fully load. To make sure JavaScript waits for all the assets to be fully loaded before it runs, I will create a simple event listener for a load event. Load event will wait for the entire page to be fully loaded and available, including page content such as style sheets, images, and so on. In the meantime, this text that says loading will be visible, so if you add more art assets, user will see this loading screen for however long it takes to load all assets. When everything is fully loaded, this event listener will run its code, and inside I will target this loading text and I will hide it, because the page is fully loaded at the point when this code runs. I will also set up my canvas, so document.getElementById canvas1. I instantiate context object, which contains all built-in 2D drawing properties and methods we will need today. I set canvas width to window inner width and canvas height to window inner height. I can see canvas is now full screen, so I make it transparent. It's time to draw the player. In player.js, I create a class I call player. Player always needs to be aware of boundaries of game area, since we will be running and jumping around, and we need to know when we reach the edges of screen, so I will pass it game width and game height from the outside as arguments. And I will convert these arguments to class properties like this. Today we are learning about state management. We will be swapping player between different states. This .states will be an array, and each position in that array will be one possible player state, such as running, jumping, sitting, and so on. Then we will have this .current state property, because player can only ever be in one state at one time. Current state will be one of the options from this .states array. So for example, this .states index 0 will be standing state, index 1 will be jumping state, and so on. This .states is an empty array now, but we will fill it with states very soon. This .image will be the doc sprite sheet. I already loaded it into our project on line 12 in index.html, so here I just point this variable towards it using its doc image ID I gave it. The doc image is a sprite sheet with multiple frames. When you divide width by number of frames in the longest row, or you can think of these as columns, you will get width of one frame. In this case, it's 200 pixels. Height divided by the number of rows will give us the height of a single frame, in this case 181.83 pixels. Let's first draw it at x and y coordinates 0, 0, so from the top left corner of canvas area. I create a public draw method that takes context as an argument to specify which canvas element we want to draw on. I call built-in canvas draw image method. I pass it my doc image from line 7 and I draw it at coordinates x and y. So this is our player class. Creating a self-contained class that handles all player functionality is a good example of the first principle of object-oriented programming called encapsulation. Encapsulation means we wrap variables or data and functions that operate on that data into objects. Encapsulation can be used to protect our data from unwanted outside access. It simplifies maintenance of our code by keeping it organized and easier to understand. Since we are including our main script.js file as a module and we are running our code through a local server, we can use export-import statements. Native JavaScript modules are part of ES6 standard and allow us to split our code into separate files, so-called modules. Members of these modules, so classes, functions and variables, can be exported and imported around our program wherever they are needed. I want to export my player class. There are two types of exports: named exports and default exports. Each module, each file can have only one default export, but there is no limit on the number of named exports. Named export looks the same, just without this default keyword. To make my player class available in main script.js file, I go up top and I say import player from player.js. This // means that player.js file is in the same folder as script.js. Since player is a default export, I don't need brackets. For named exports, exports that don't have default keyword in front of them, I would have to wrap them in brackets like this. But since player class is a default export, we don't need brackets here, and I can also refer to player using default here. But there is no need to go into that much detail about modules today. I just want you to understand the main idea and get comfortable exporting and importing your variables, classes and functions between modules. So now, player class is available here. Let's test if it works and instantiate it. I create a constant variable called, for example, player, and I set it to new player. Here on line 2 in player.js, I can see our player class expects game width and game height arguments, so I pass it canvas width from line 8 and canvas height from line 9. If I console log player, I can see my object here and I can inspect it to see all its properties and values. Congratulations, now you understand how to use native JavaScript modules. What else should we learn today? Click the like if you are getting any value. We created a public draw method on our player class, so let's call it here. I have an error because draw method needs an argument for context, otherwise it doesn't know what canvas to draw on. I pass it ctx from line 7 because in this project we only have one canvas element. Nice, we are drawing player image on canvas. What you see on canvas right now is the entire sprite sheet. On line 14 here, we are telling draw method what image to draw and what coordinates to draw it at. Draw method will just take the entire image at its original size and it places it at these coordinates. I can change the coordinates here. Built-in canvas draw image method can take 3, 5 or 9 arguments, depending on how much control we want to have over the image we are drawing. If I give it optional 4th and 5th arguments, these stand for width and height, and the entire image will be stretched to fill the rectangle defined by these starting coordinates and these ending coordinates. The last, longest version of draw image method expects 9 arguments and it gives us full control over the image. We pass it image we want to draw, x, y, width and height of rectangle we want to crop out from the source image, and x, y, width and height of rectangular area where we want to place that cropped out piece of image on destination canvas. So right now I want to draw just a single frame from player sprite sheet. So destination values will be this.x, this.y, this.width and this.height. And source values will be, let's start by cropping out this frame in the top left corner. So from coordinates 0, 0 to coordinates this.width, this.height. These two values determine start of cropping rectangle, so I can navigate around the sprite sheet horizontally and vertically just by changing these two values. Now I'm traveling along the sprite sheet horizontally. It's not very obvious on this simple standing animation. If you watch Doc's tail, you will see we are swapping between frames. Source Y argument here is for vertical navigation. Now I jumped to this frame. I can swap between frames just by changing these values. I might as well put them into separate variables. I create frame X variable for horizontal navigation and I replace it here. I also create frame Y for vertical navigation and I replace it here. Now I can jump between frames in our sprite sheet by changing frame X and frame Y variables. Wow, we covered the main principles of JavaScript sprite animation so fast today. I have a special class about it if you want to go deeper. To finalize sprite animation, we just rotate between sprites on each row endlessly using frame X property, and as we swap between different player states such as running and jumping, we will be swapping between rows of sprite sheet vertically using frame Y variable. Before we do that, let's place player in the middle bottom of canvas to make it seem like it's standing on the ground. This.x is game width divided by 2 minus player's width divided by 2. And middle bottom placement is game height minus height of the player, like this. There are many ways to handle keyboard inputs. I want to keep our code clean and modular, so I have this input.js file. Inside, I create a default export again, and this time it will be a class called input handler. This class's job will be to set up listeners for specific keys and to keep track of the last key that was pressed or released. And it will have only one class property called, for example, this.lastKey. This value will be updated every time one of our selected keys is pressed or released. Inside constructor, I create an event listener for key down event. Callback function on event listener in JavaScript has this auto-generated event object that is automatically passed as an argument here. I will refer to it as E, for example. This E event object has all kinds of different information about key down event that just occurred. You can console log E to see it. I used it many times before, so I know this event object has a property called key that gives us the name of keyboard button that was pressed. I could use if-else statements here, or I can use a JavaScript switch statement, which is used to perform different actions based on different conditions. We use it to select one of many blocks of code to be executed based on which key was pressed. The syntax goes like this. I open switch statement and I pass it expression to validate. In this case, I wanted to check for value of event.key, which contains name of the key that was just pressed in this key down event. I say case arrow left, and here's some code to be executed if e.key is arrow left. In this case, I will take this.lastKey from line 3 and I give it value press left. Make sure you spell it the same as me, it's case sensitive. We can have multiple cases here. So far I just have one, but I will add more arrow keys in a minute. Switch expression on line 5 is evaluated once and it is compared with each case. In this case, it will check if e.key is equal to arrow left. If it is, code on line 7 will be executed. We can also give it default case with code to run if there is no match, but I will not be doing that today. Let's copy this event listener and I change it to key up event. When arrow left is released, I will set this.lastKey from line 3 to release left. This way I can keep track of specific keys being pressed and released. I console log e.key inside key down event just to check if everything works so far. So I have this custom input handler class and all this code is inside its class constructor, which means all this code will get auto-executed when I create an instance of this class using the new keyword. Instantiating input handler class will automatically attach these two event listeners to our browser window object. I'm exporting this class here and I will instantiate it from a main script.js file by saying import input handler from input.js. With input handler class available, I create a constant variable called, for example, input, and I set it to new input handler. That's it. Now, when I click my canvas and I start pressing keyboard, it will console log names of those keys. Those names are values of key property on auto-generated event object, coming from e.key here. So creating an instance of input handler class automatically executed all the code inside its constructor, which added event listeners to our project. We care only about certain keys, we will ignore others. Right now, pressing and releasing left arrow key will update this .lastKey property. Last key stores the last keyboard input that was pressed or released. I will add more keys. In key down I add case for arrow right and I set last key to press right. And in key up event listener we set it to release right. I will add break keyword after each case. If we find a match, we don't have to check the others. So we are listening for presses and releases of left and right keys. Let's see if everything works. I console log input from line 14, .last key, which is coming from line 3 in input.js file. It's not working because we have a problem with this keyword. Since I'm attaching event listener to window object from inside a class, I need to bind that reference to this keyword so that when event listener runs this line later, it still remembers that this keyword stands for this property on input handler object. I can use built-in JavaScript bind method here, or I can use ES6 arrow function syntax, which has a special built-in feature when compared to regular function. Arrow functions do not bind their own disk, but they inherit one from their parent scope. This is so-called lexical scoping. Because of this behavior, arrow functions allow us to retain the scope of the caller inside the function, so we don't need to use bind. In other words, using arrow function here will make sure these lines of code will correctly remember we are pointing them to this class property. I will also need animation loop, so custom function I call for example animate. Inside I will console log input.lastKey. Request animation frame and I pass it animate, which will create an endless animation loop. I start the loop by calling animate like this. Now when I click on canvas and I press left or right arrow keys, we get the correct console logs for left. I misspelled arrow right on lines 9 and 19. Now everything works great. Utils.js is just a place where I can have my small utility functions. I want the function that will display the last key that was pressed. I want to draw that text on canvas so that I don't have to check console. It will be very simple. I call it draw status text. It will take arguments for context to specify what canvas we want to draw on and input so that we have access to the last key value. I set canvas font property to 10 pixels Helvetica, for example. Fill text method takes text we want to draw and x and y where on canvas we want to draw it. So I pass it last input, space plus input.lastKey, and I want to draw it at coordinates 10, 20, I guess. Let's export it and import it in script.js. This time I'm not exporting it as a default, so I have to wrap it in curly brackets like this. I import the draw status text in brackets from utils.js and I call it inside animation loop here on line 19. It expects context and input as arguments, so I pass it ctx from line 9 and input from line 15. Let's make it larger, maybe 30 pixels. And coordinates 20, 50. Nice, it works. I need to make sure I clear my canvas between frames to delete old paint. Built-in clear rectangle method, and I want to clear the entire canvas from coordinates 0, 0 to coordinates canvas width, canvas height. This will delete my player, so I have to redraw it for every frame by placing player.draw inside animation loop. Nice. So far we only care about left and right arrow keys. When we press them, canvas gets updated. Let's delete this console log. State design pattern allows objects to change their behavior based on their current state. In this case, we will start very simple to demonstrate the main idea. We will swap player between stand in left and stand in right state. Entering each state will draw a different row in Sprite sheet, and in each of these states, player will only respond to a limited set of keyboard inputs. When we are standing left, we will ignore additional presses of left key and we will only react when user presses the right key, which will swap us to standing right state. In standing right, we will ignore any additional presses of right key and only pressing left arrow key will swap us to standing left state. In each state, we can limit what keys player will react to, and we can write logic that defines behavior for each key press separately. I will keep all potential player states in this .states array here, and I will keep track of the current one in this .current state here. The way this is done is that each state in this .states array will be its own object, generated by a separate class. Don't worry, let's go through it now and make sure we explain it properly so that it's easy to understand. In state.js, I will define class for each state. I will have an object that will contain a list of all possible states. Usually it's a good idea to use enum for this. In this case, we will use enum to define a set of named constants. We define a name for each state and assign it a number. The order of these states must match the order in which we add them to player states array. And that way, swapping between states will be more readable because instead of swapping to state 0, I will be able to swap to state standing left, for example. It will make our code easier to read, that's why we're writing this enum statement. I will have just two states at first to demonstrate the entire logic on a simple example. Standing left will be state 0 and standing right will be state 1. I create a custom class called state. Its job will be just to hold this .state property, which will be passed to constructor as an argument. It will take this argument and it will turn it into class property. This is just to keep track of name of the currently active state so that we can write that state name on canvas. In state design pattern, each state is usually defined by a separate class. So let's create a class called standing left, and that class extends state class from line 6. Extends keyword is used to create a child class. By extending a class, I'm setting up a relationship between these two classes. This is parent and this is child. Extending classes is a good example of one of 4 pillars of object-oriented programming called inheritance. Inheritance is a process where one class inherits attributes and methods from another class. We use it to avoid code repetition. I will create multiple child classes that all extend this state class. If I want, I can define a method on parent state class and it will be inherited by all child classes automatically so that I don't have to define them on each class separately. All child classes will also have access to this .state property because if I reference a method or a property from inside a child class, if JavaScript can't find it on this class, it will go look for it automatically on the parent. So this is our parent class, also called superclass, and this is so-called child class or subclass. It will have its own constructor, and that constructor will expect player object as an argument because I need access to player properties on here, since I want to be changing things like player sprite sheet row or player speed as we swap between different states. Constructor is automatically executed when we create an instance of a class, so the first thing I will do is use super keyword. We can use super keyword in child classes to access and call methods on object's parent. When super is used in a constructor, like we are doing here, it must be used before this keyword. Calling super here will execute all the code inside the parent constructor on line 7. In this case, we need to pass it name of current state, standing left, and constructor will set it as a value for this .state class property on this particular subclass. We will just use that to write currently active state on canvas a bit later. Now I take player object passed as an argument and I convert it to class property here. My standing left child class will have enter method that will do everything that needs to be done when player enters this particular state. For example, it will change its speed or sprite sheet. It will also have handle input method, which will listen for a predefined set of inputs and swap to a different state when the correct key is pressed. Enter method will just run once when standing left state is entered. Handle input method will run over and over per each animation frame. Let's copy all this and make another child class called standing right. I pass standing right string to its superclass constructor. Notice that we have two subclasses extending one superclass. Both of these child classes have methods that are named exactly the same. This is very important. Placing methods with the same names on different objects is an example of one of the core concepts of object-oriented programming called polymorphism. Out of these four concepts, it's the most complex one to fully understand, since it has multiple types. In this case, polymorphism allows methods to display different behavior depending on which class calls it. We will be calling enter and handle input methods from player class using the same line of code every time, but as player swaps between different states, different code will be executed because enter method and handle input methods will contain different behavior for each player state, for each class. Those differences will be defined here. So for this code to work, every player state class we define needs to have enter method that runs once every time we enter that state to set things up, and it needs to have handle input class method that runs continuously, waiting for specific inputs to be pressed to switch player object to a different state. Handle input method will take input as an argument. Player object has this.frameY property, which determines which row of player sprite sheet we are animating. When we enter stand in left state, I want to animate row 1. Stand in right animation frames are on row with index 0. The main principle of state management pattern is that when in specific state, object will only react to a limited set of inputs. Other inputs for which we don't define behavior here will be ignored. So inside stand in left class, if input is press right, we will set state to stand in right. When player object is in stand in right state and input is press left, we will switch player to stand in left state. And the final piece is the mechanism that will actually allow us to swap player to a different state. That code will come here. I create a custom public method on player class called, for example, setState, and it will take the new state as an argument. Inside, I set this.currentState from line 6 to this.states from line 5, and index will be this state number we passed as argument. Of course, this will only work if this.states actually contains some states. Right now it's empty. We will fill it in a minute. We know that each of our states has enter method, which will run once when player enters that particular state to set up our sprite sheet, to make sure we are animating the correct row. Back in set state, we switch player to a new state and we call that enter method. If we pass it 1 here, enter method will be called on stand in left state. If we pass it 0 here, method will be called from stand in right state. Because in our enum, we gave stand in left state a value of 0 and stand in right state is value 1. So now we have a public method that can swap player between different states. If player is currently in stand in left state and handle input method detects that we pressed right arrow key, we call it this.player.setState, and on line 18 here, I see it expects state as an argument. That argument will be a number. Right now we only have 2 states, so either 0 for stand in left or 1 for stand in right will come here. You can see we say this.states and index in square brackets, so we are referring to this.states from line 5. Again, we will fill this array with state objects in a minute. So I want to swap player to stand in right state here. I can see stand in right is 1 here, so to pass it number 1, I pass it states from line 1 dot stand in right from line 3. This entire enum object is here just to give me more readable values to these numbers that represent states. It would also work if I just passed it number 1 directly here. That number 1 passed the setState method will be passed here on line 18 as an argument, and this.currentState will be assigned this.states from line 5 index 1. This array will need to have 2 elements as we have 2 states, element with an index of 0 and element with an index of 1. These will not be just simple numbers like this. These will be entire instances of stand in left and stand in right class. But before I can use those classes here in player.js, I need to import them. To import multiple classes from the same file, we need to wrap them in brackets. In state.js, I export stand in left class from line 10 and stand in right class from line 22. In player.js, I import both of them from state.js like this. I need to make sure I save changes to all files I made changes to. I have an error because I didn't finish this other if statement. If player is in stand in right state and handle input method detects we pressed left arrow key, call set state on player class and pass it number 0, state.stand in left. This stands for 0, so 0 is being passed here to set state, and this.current state is set to this.states from line 7 index 0, which is this. Now we can finally define our states here properly, so index 0 in player states array will be an instance of stand in left class, so new stand in left, and index 1 will be new stand in right. We need to make sure that state objects in this array have the same indexes as numbers we defined for each of these states inside enum here. Now that we can swap between states, I also need to be calling the handle input method over and over so that we can listen for new inputs and change states when needed. I create update method on player class and it will take input as an argument. Inside this method, I will be periodically calling handle input from this.current state property from line 8. This property represents currently active state. Because of logic we defined on line 24, so player will be either in stand in left or in stand in right state. It will call either handle input method from line 19 that reacts only to press right, or handle input method from line 30 that reacts only to press left. I call it like this and I pass it input that we passed here as an argument. That input then comes through here so that handle input method can check what was pressed, and if the right key is pressed, it will swap player states. We call player update we just wrote from animation loop and I pass it input from line 17 dot last key from line 3 in input.js. We are done. We just wrote the entire logic for state management of player object. Let's quickly follow the logic one more time to make sure it's clear. We are calling update method for every animation frame and passing it input.lastKey, the last key from selected inputs that user interacted with. That input last key is passed here. This time I call it just input and I pass it to this.current state from line 8. .handle input, and I pass that same input value along. This.current state represents the entire state object. At first I'm setting it to this.states index 0, which is this stand in left object. So for this animation frame, handle input will be called from stand in left class, so from here. I can see constructor for stand in left and stand in right expects player as an argument so that we can then correctly set up our sprite sheets here and here. Inside player.js I need to pass it that player argument. Since we are inside player class right now, I pass it this keyword, which in this scope of this class represents the entire player object. Okay, so this.current state is this.states index 0, which means our stand in left class, and we are calling handle input on it, so handle input from line 18 will be called. If the initial current state is index 1, that would be stand in right state, so this handle input method will be called from line 30 instead. If handle input is called from stand in left class, it will only react if right arrow key is pressed, and it will swap player to stand in right state. If player is currently in stand in right state, handle input will only react to left arrow key being pressed, and it will swap player to stand in left state. Whenever we set a new state, it will update which of these two states this.current state is pointing towards, and then from that new state it will call this enter method. Enter method was defined on lines 15 and 27, and depending on the current state, it will set sprite sheet to animate a different row. I save changes to all my files, and when I click my canvas and press left and right arrow keys, we are correctly swapping between stand in left and stand in right state. Let's display what state player is currently in on canvas as well. Here on line 24, every time set state is called, we set this.current state from line 8 to one of our available states. So far we have stand in left at index 0 and stand in right at index 1. Parent class of all our states has this.state property in its constructor. We are given that property a different value from each child state by calling superclass constructor from each subclass. Basically all that this is, we are declaring this .state property on parent class. That property is being inherited by all child classes and it's set to standing left on this class on line 12 and to standing right on this class on line 24. I just want to draw this value on canvas so that we know currently active state. I will use our existing drawStatusText function for that. We are calling it from inside animation loop here, and I need to pass it player object so that we can access current player state. Here I make sure my function expects that argument the same as we did with input last key. I will call fillText and I say active state colon space plus player we passed as argument dot current state dot state. When current state is set to standing left, this dot state here will be set to standing left, and that's what will get displayed. For standing right, it will display this line. As I said before, using super keyword inside child class constructor, we'll call constructor of its superclass, its parent class, and it will execute all its code. In this case, this code will assign value of standing right to this inherited state property. When using live server in VS Code, watch for these dots here. It means you have unsaved changes in your file, so just make sure you save all your code in each file if you're not getting the same result as me. I save my changes. I also have to give fillText some x and y coordinates. How about 2100? Maybe 90? And I reduce font size to 28 pixels. When I save my changes and interact with canvas, now when I press left and right keys, we see status text that tells user the last input that was pressed or released and currently active player status. That's it, state pattern is complete. Now we just add more states by extending it. Before we add sitting and running state, let's recap the logic because I realize this must be a lot for beginners to follow. If you are following so far, well done, you are doing great. It all starts by calling player update and passing it the last key that was pressed or released. Inside update method, we take that input and we pass it along to handle input method. The whole trick here is that we are calling handle input from this .current state property, which swaps between different states. When we pass it 1, it points to state with index 1 inside this .states array, so in this case standing right object. If it's 0, it points towards standing left state object. Both of these objects have their own version of handle input method, so that as we point current state towards different state objects, behavior of player will change even though we are always calling the same handle input method. It's important that all our state objects have their own definition of enter method and handle input method. I could also create a backup enter and handle input method on their parent class here, in case child class doesn't have methods with these names, but let's not overcomplicate things. I like to think of this type of state management as we are locking player in different states. While player is in a specific state, it will ignore some inputs and it will only react to inputs we define in its handle input method. Here we can see that while in standing left state, player will only react to pressing right arrow key and it will make it switch to standing right state. While in standing right state, player will ignore all inputs except for pressing of left arrow key, which will make it swap to standing left state. You might notice that state design pattern has some code repetition, but the code is easy to navigate in, and if we get a bug, it will be limited to a specific state, making larger projects much easier to manage and debug. If we get some unexpected behavior, we can see what state was our player object in when that unexpected thing happened, and what was the last input key that was pressed or released. And we check our code inside handle input method on that particular state to see what went wrong. Structuring your code like this comes very useful when you want to give your player multiple abilities, weapons, and special moves. We are capturing the last key that was pressed here inside our input handler class. I'm importing and instantiating that class here in script.js and passing it to player update method. We pass that input value along to handle input method, and value of that input gets checked against a set of specific values we define for each state, and based on that we swap player to a different state using our custom setState method. setState method takes a single number as an argument, as we defined them inside enum. State.standInRight is 1, state.standInLeft is 0. So right now I'm basically passing it number 1 here. That number travels as an argument passed to setState here. It's passed along here and it represents index of that state inside this.states array on player class. So number assigned to each state inside enum object in state.js have to correspond to index of each of these particular states inside this.states array on player class. That way, when it receives number 1 here, it swaps to stand-in-right state. If it receives number 0, it will set state to stand-in-left. After swapping to a specific state, enter method will run once to set up player object for entering that state. In our case, we just adjust sprite sheet row for now. And then it continuously calls handle input method from that state class, which listens to specific set of keyboard inputs. That's why we have enter and handle input methods with the same names on each state, so that we call them from the same place, but we get different behaviors depending on which state object is player.currentState pointing towards at that particular moment. Let's add sitting state. I copy this code block and case will be arrow down. If you want to know what are the values of e.key so that you can check for correct spelling of key names, you can just console log it here. I'm going to say if e.key value is arrow down, set this.last key from line 3 to press down. In key up event, we set it to release down. In state.js, I copy this code block. I use it to create a new class called sitInLeft. I pass it sitInLeft here. I check my sprite sheet and I see that sitInLeft animation is on row 9. We are counting from 0. While in sitInLeft state, if we detect that user pressed right key, we will swap player to sitInRight state, which we will create in a minute. Else, if we detect that user pressed up arrow key, we will make it stand up again. I need to create these new key value pairs in my enum object up here, so sitInLeft will be 2 and sitInRight will be 3. In input.js, I will check if pressed key is arrow up, and I set last key to press up. In key up event, I set it to release up. So now we are tracking presses and releases of all 4 arrow keys. Perfect. In my new sitInLeft class, when we press right, we set state to sitInRight, and when we press up, our dog will simply stand back up. So here I need to do stand-in-left because we are going from sitInLeft state. I copy this code block and I turn it into sitInRight class. We set name of state to sitInRight so that it displays correctly here. While in sitInRight state, if we press left, we set state to sitInLeft. If we press up, we set state to stand-in-right. In player.js, I import these 2 new state classes. I instantiate them inside this.states array while making sure I am adding them in the right order. Nice, so we have 2 new state classes. I hope you can see now how state pattern limits the number of inputs player reacts in each state. We have logic that defines how player behaves while in these 2 new sitting states, but we have no way to actually enter these sitting states. I go inside stand-in-right class and I say if input is pressed down, we set state to sitInRight. If we press down while in stand-in-left class, we set state to sitInLeft. I also need to make sure enter method on sitInLeft class sets player sprite sheet to the correct row. SitInLeft is row with index 8. Actually, sorry, sitInLeft is row index 9, sitInRight is row index 8. Now it's correct. I will also set the initial state to stand-in-right, so this.states index 1, just for the first page load before we start pressing keys and swapping player states. Now, when we press the down arrow key, player will sit. We can press left and right keys to make player turn left and right while sitting, and pressing up arrow will make it stand up and face the correct direction. This is going really well. We can also change how the entire sitting state works by only making the player sit while arrow down key is being pressed, and when it's released, player will stand back up automatically. So inside sitInLeft state, if input is released down, we set player to stand in left. And inside sit in right, we set player to stand in right. It really depends on what kind of game you are building and what player behavior you want. I hope you can see that you get a lot of freedom and flexibility with this code structure. You can easily control every detail of player behavior when you structure code like this. The way I wrote this code, we only react to the last key pressed. I'm not keeping track of multiple key presses in memory since I want to keep this simple, but I will cover how to handle pressing multiple keys at the same time in a special episode as well, probably. Adding running states will be similar, but we will have to handle horizontal speed, so let me show you how to do that. Again, I start by adding new states inside my enum. Running left will be state number 4, running right will be number 5. I make a copy of this block and name it running left. I put running left here. I check my sprite sheet and the row for this animation is 7. When we release left while in this state, we will switch player into standing left state. And when we press right, we will switch into running right. I also copy this line of code from here, and when we press down from running left state, we will go into sitting left state. Duplicate this and turn it into running right state. If we press left arrow key while in running right state, we will switch into running left. If we release right key, we will go into standing right, and pressing down arrow key will make player sit to the right. Not every game needs to have left and right version of each state. Also, there are other ways to write code when you have a set of states that each has left and right version, or maybe each state has a version with weapon ready and weapon hidden, for example. Again, I'm doing it like this for simplicity and to demonstrate the main idea of my version of state management pattern. So we defined behavior for player while in running states. Now we need a way to actually enter these states. We can enter running from standing state, for example. While standing left, if we press right, we set state to running right. Here inside running right state, we see that when we release right key, it will switch back to standing right state. So we are only running as long as the key is being pressed down. If we press left while in standing state, we will start running to the left. I get this error because I refreshed my project before I finished adding new state on player class. Don't worry about that. While in standing right state, if we press left, we will start running left. If we press right, we will start running right. So here we are exporting two new state classes we just wrote. Here we are assigning them values 4 and 5. These numbers need to correspond to indexes to order in which we add these states inside this .states array here. First, I import them on line 1 as usual, and then I add instance of running left class as index 4 in this array, and running right will be the 5th item in this array, counting from 0. I save changes to all my files. Running right animation is row 6 in our sprite sheet. Perfect. It works and swaps between running and standing states correctly. We also want player to actually move when in running state, so let's give it this .speed property and set it to 0. Then I create max speed property and I set it to 10 pixels per frame, for example. When we enter running state, we set player speed to player max speed, and in running left, we set player to minus player max speed because moving left is in the negative direction on horizontal x-axis. Inside update method on player class, I will be adding player speed from line 16 to horizontal position from line 12. Problem now is that player will just move off screen because even when we switch away from running state, nothing is setting player speed back to 0. So when we enter standing left state, we set player speed back to 0. We do the same thing inside enter method on standing right, sitting left and sitting right state. Perfect. Player now stops moving when we enter standing or sitting state. I will also introduce horizontal boundaries so users can't move player outside the canvas. If horizontal position of player is less or equal to 0, I set the position to 0. Else if the position is more or equal to game width minus player width, meaning player's right edge is touching right edge of canvas, I will also not allow it to move past that point. This is going so well. We applied state management to our player and we have granular control over its behavior separated for each state. We can do so many things with this. Common thing you will see in games is jumping. Again, there is a new small trick we have to use here. If you never coded jumping in a 2D side-scroller game, we will learn how to do it properly right now, and we will make it look really good by switching player to a separate falling animation after it reached peak height of its jump. Let me show you that swapping between states doesn't always have to happen on user input. We can also tie state swapping to other game events. In this case, we will swap player from jumping into falling state after it reached maximum height of its jump. We are creating new states. As usual, I will first add them up here to our states object, which we are using to pair readable state names with numbers that represent each state. I copy already existing state class and I turn it into jumping left class. I check my sprite sheet to see which row has jumping left animation frames. I delete player speed, I think, because I want the speed to be inherited whether we enter jump from standing or running state. We will see about that. I delete all these inputs for now. I copy this block and turn it into jumping right class. Frame Y for jumping right is row with index of 2. I go up to standing left state, and when input is pressed, we switch player to jumping left. Inside standing right state, when we press up arrow key, we set state to jumping right. I'm exporting these new state classes, so in player.js I can import them. And I instantiate them inside player states array. I'm getting an error. It's because up here in my enum I skipped some values. Let's assign my new states to the correct values. Now we correctly enter jumping state. When I'm in that state, it doesn't matter what I press, we are locked in that state, because inside handle input method I didn't give it any way to switch off to a different state. First, when we enter jumping state, let's push player upwards on minus direction on vertical y-axis. When we enter, I say this.velocity y minus equals 20. I do the same for jumping right state. In player.js inside update method, we will deal with vertical movement here. I give player vy, velocity y property, and I give it property I call, for example, weight. I could have also called it gravity or something. I will use velocity y to pull player upwards and weight to pull player down. As the ratio between these two values changes during the jump, it will create a nice jumping curve. For every frame, we will add this.velocity y from line 14 to player's vertical y position from line 13. Right now, velocity y is 0, so even when we are adding it, there will be no vertical movement. If player is not standing on the ground, so if player y is less than this.gameHeight minus player height, gradually add value of player weight to velocity y. Else, meaning player is standing on the ground, set velocity y back to 0. Give me a second to figure this out to make sure I'm doing it correctly. In state.js here, I actually want to access a velocity y property on player object, so this.player vy minus equals 20. I get small jump and it stops moving again. Oh yeah, this is a typo. This needs to be game height. Now it's working. We have multiple places in our code where we need to check if player is standing on the ground or if it's currently in the air. This is a good time to create a small utility method on our player. I will call it onGround, and its job is to check if player is standing on the ground. I will just make it return true or false directly like this, based on how this expression evaluates. If player's y-coordinate, which is the top edge of player image rectangle, if it's more or equal than game height, so this point, minus player height, so if this point is more or equal than this point, we know player is standing on the ground, so this method will return true, else it will return false. Now I can just call this method whenever I need to do this check, and it will also make the checks more readable. Here on line 32 I'm checking if player is not on ground, so I say if on ground is false. Actually, if this.onGround is false, now it's working. I want player to be able to switch sides while jumping. So in jumping left state, if we press right arrow key, we set state to jumping right. In jumping right state, if we press left arrow key, we set state to jumping left. Player is flying off screen really far. Let's change this to minus equals 10. That's a very small jump, but you will notice a bug here. If I swap between jumping left and jumping right quickly, each time we enter these states, we are running their enter method, so each time we push player further and further up. I want the player to only be able to propel itself further up if it's standing on the ground, so in enter method on both jumping states, I will first check if player.onGround is true before we push it upwards. If it's already in the air, this will be false and player will receive no vertical push. I change these values to minus equals 40. I just make sure I spell on ground correctly. Perfect, we are able to turn to sides while jumping. I will actually give it some horizontal speed as well. When we enter jumping left, set player's horizontal speed to half of player's max speed. And the same for jumping right. In jumping left, it actually has to be negative number, since we want to move in minus direction on horizontal x-axis. That works awesome. I can switch between jumping left and jumping right states, but otherwise I'm locked in jumping. I didn't give it any way to get back to running or standing state. Inside jumping left, I check if player on ground is true, and when player gets back on the ground, we set its state to standing left. In jumping right again, we check if player is back on ground, and we set it to standing right. We are running, standing, sitting and jumping. Well done if you followed this far. Let's polish this and make it look even better. Jumping works this way. We are always adding velocity y to player's vertical position here on line 31. Most of the time, that velocity y is 0, so there is no vertical movement. When we enter jumping state, we set velocity y to minus 40, which will push player upwards, in minus direction on vertical y-axis. When that happens, player is no longer standing on the ground, so this if statement triggers, and we start increasing velocity from line 14 by player weight from line 15. This happens for every frame step by step, so actually velocity y goes from minus 40 to 0, making player move up slower and slower. When it's 0, player will stop moving. At that point, we are still not on the ground, so this line of code keeps increasing and it moves velocity y from negative to positive numbers, which will make player reach peak of its jump and it will start falling back down. When we touch the ground, this else statement triggers, velocity y is set back to 0 and vertical movement will stop. Understanding how velocity y goes from minus 40 to 0 and then into positive numbers gives us ability to tie player state change to it. I can tell that player is at its peak of its jump because its velocity y switched from negative to positive values. I will just add a quick check here to make sure player doesn't fall through the floor. It shouldn't happen, but this is kind of my insurance. If player y is more than game height minus player height, set player y to game height minus player height. This line will make it impossible for a player to move below ground level under any circumstances. I don't think this check is needed. Even when I increase player weight to 10, we still don't fall through the floor. Maybe you can just comment it out, it's up to you. It's just a check to be secure. I created falling states. Falling left is 8 and falling right is 9. I copy one of my state classes and I turn it into falling left. Enter method will just set frame y to 5. Inside handle input method, while in falling left, if we press right arrow key, we want to turn, so we will switch to falling right. I also want to keep this check. When we fall all the way to the ground, we will switch player to standing left state. I copy this and turn it into falling right class. Frame y here will be 4, and when we press left, we set state to falling left. I import these classes in player.js and I instantiate them inside player states array. So how do we enter falling state? As we said, when we enter, jump velocity y is set to minus 40 and we start adding player weight to it. So it goes all the way to 0 and into positive numbers. I know at the point velocity y reaches 0, we are at the peak of jump, and as it goes into positive numbers, player is falling back down. Bear with me a second here, please. So inside the jumping left state, if velocity y on player object is more than 0, we set player state to falling left. Inside the jumping right state, if velocity y is more than 0, we set state to jumping right. So this is one example of how you can switch states based on other conditions. State changes don't always have to be triggered by user pressing keys on keyboard. This works really well. We created stand-in, sit-in, run-in, jump-in and falling states. We are just drawing the first frame in each sprite sheet row. Let's actually animate the frames horizontally. We have frame X property for horizontal navigation within our sprite sheet. For every animation frame, I check if frame X is less than max frame and I increase frame X by 1. I set frame X back to 0. Some rows have different maximum number of frames, but that's easy to deal with. Initially, I set max frame to 5. We are counting from 0. You can see that sit-in animation has less frames, so it's blinking since we are animating empty frames. We will start with stand-in animation, so the initial max frame is 6. Every time we enter a new state, we set max frame to a different value. When we enter stand-in left, we set max frame to 6. Probably I should be setting max frame before I set frame Y, because in some cases if I switch row at first, we can get blinking before the right max frame is applied. Or maybe I could also set frame X to 0 every time we enter a new state. I'm not gonna go deep into this today. I made other episodes about sprite animation. This is just a quick solution. Running left and running right will set max frame to 8. Jumping and falling have max frame 6. Awesome, we are correctly animating all our rows. If you want to make a player move faster, you can change max speed property here on line 20. This value affects horizontal movement. The sprites are animating very fast. Maybe I want to slow them down a bit without changing FPS of the entire game. How do I set FPS for how often we switch between horizontal frames in sprite sheet while still keeping everything else running at maximum 60 FPS? As always, we can use timestamps and delta time. Last time will be the value of timestamp from the previous loop. Animate takes this auto-generated timestamp argument, which was produced and automatically passed to it by request animation frame from line 23. Delta time is a number of milliseconds that passed between the last animation loop and this animation loop. It's the difference between timestamps from each loop. So delta time equals the timestamp from this loop minus timestamp from the previous loop. When we have that calculation, I set last time to the current timestamp so that it can be used for the next loop. I also have to pass animate the initial timestamp just for the first loop because request animation frame auto-generates it from the second loop onwards. So now we have delta time. We know how many milliseconds it takes for our computer to serve the next animation frame. It depends on power of our machine, how much animation and calculations our game is doing per each frame, as well as on refresh rate of screen we are using. This number can be different for every computer, but we can use it to unify how our game runs across different machines. Today I will use it to control how often we serve the next horizontal frame in doc sprite sheet. I pass delta time to player draw method here, and in player.js I make sure draw method expects that argument. Timing things with delta time needs 3 helper variables. One variable to set FPS, frames per second, one timer variable that will accumulate delta time until it reaches a certain value, and one variable that defines that value we want to reach. I call that value frame interval, and it will be 1000 milliseconds divided by frames per second, which will give me number of milliseconds I want each frame to be displayed on the screen before we switch to the next one. So if frame timer from line 22 is more than frame interval from line 23, only then switch frame X variable. At the same time, set frame timer back to 0 so that it can count again. Else, just increase frame timer by delta time and wait until it accumulates enough milliseconds. It's not working. I see, here in animation loop, I need to correctly assign last time to the new timestamp value after we used it to calculate delta time so that it can be used to calculate delta time in the next loop. If I change FPS, it affects how fast we serve horizontal sprites while still allowing player to move around at maximum 60 frames per second or whatever your request animation frame can handle on your computer. If I give it FPS that's higher than my screen's refresh rate, request animation frame will automatically cap it, so it won't animate faster past a certain value. That maximum value of frames per second is limited by your screen's refresh rate. Do you want to learn more game development with me and practice HTML, CSS and JavaScript at the same time? You can check out these videos. I'll see you there.